Hello and welcome to the Wireless LAN News Desk here on February 9th, 2018. My name's Tom Carpenter, I'm the CTO at CWNP, and this week in the news there were a couple of interesting things. First of all, an article at WiFiNowEvents.com caught my attention. It was about Trackside Wi-Fi. Now, here's the thing we're looking at. With trains, providing Wi-Fi to passengers and also using Wi-Fi for communication of train information such as video surveillance and route information and updates and location and so forth, has in the past used cellular LTE uplinks. And the latency, of course, was high and the actual throughput was not always what it needed to be and so forth. So a modern movement is let's do trackside Wi-Fi. Now the concept is that you actually have just really pretty much regular wireless access points on the train that passengers can connect to and that employees can connect to and that they use for typical internet access and access to other applications on the network. Then the trains actually connect to trackside wireless access points. These could be proprietary or they could be 802.11 based. The key here is they have to be spaced apart with enough frequency that the train can always have a good, solid, high-speed connection to them. And in addition to that, they have to be able to roam or transfer very quickly. Now, keep in mind, with trackside Wi-Fi, the users don't roam, right? They're on the train, connected to a Wi-Fi access point on the train. So they're going with the train, they're going with the access point, and therefore they don't actually roam. What roams is the train itself, roaming from one trackside device to another trackside device. Now, many vendors claim as low as just under 1 millisecond roam times. The goal, of course, would have to be somewhere 30 to 50 milliseconds as a maximum roam time to make sure you're not losing connections for users on the train. But why do we really aim at way down there at closer to minus 1 millisecond? Well, the reason is that you have to think that there could be 50, 60, 70, 100 people or more on that train using applications that need low latency. Now, since they all have one connection from the train to trackside, you have to realize that they're all vying for that connection when it is available. So we need it to be available as much of the time as possible. Now, there are several vendors that are players in this space. For example, we have Cisco as a primary vendor for several years now. They've had design specifications for building trackside Wi-Fi that uses either LTE or takes advantage of true trackside Wi-Fi. And then we have other vendors that play specifically in the space for providing those trackside access points that are designed for very low roam times. For example, some of them promising that less than 1 millisecond roam time. So this is key. And then of course on the trackside side, you have to have those access points connected to something. They could be connected through a backhaul that is itself wireless. They could be connected through fiber that's run along the tracks. There are any number of possibilities there, but this is the crux of this thing that we call trackside Wi-Fi. So it's another interesting deployment and use of Wi-Fi. To learn more, of course, you can visit Cisco's website, do a search for trackside Wi-Fi on the internet in general. You'll find several vendors that are talking about it. And keep in mind that the APs that are on the trains are really just APs. So you could effectively use any vendor's enterprise APs on the train cars. And then, of course, you're going to need an uplink from the train to trackside. Now, the other thing that was in the news this week is that AVX is acquiring Ethertronics. I've talked about Ethertronics in the past. They have antenna technology that is simply called active steering. So the antennas are able to focus the communications better for both transmission and reception, giving a roughly 3 dB of gain, which can be significant. But one of the other things that they talk about is how their antenna systems have advanced filtering capabilities. So I thought it would be useful to talk just a bit today about filtering within wireless APs and wireless devices in general, and what we mean by it and why filtering would be done. We're not talking about filtering at the network level where we're dealing with TCP or IP communications. We're talking about filtering at the physical layer where we're dealing with electromagnetic frequencies. So what we can do is filter out unwanted frequencies, such as adjacent channel interference or something like that, and filter in wanted frequencies. When we're filtering in, we call that the pass band. It's the band that's allowed to pass. And then, of course, we can have high and low filters on either side of that pass band. So filtering is used in this way to filter out what you don't want and filter in what you do. And better filters result in better communications. Now, I thought it might be useful to help you understand this concept of filtering to move over to a different world of waves, and that's audio waves. We have audible frequencies that we process in audio engineering. So what I'm going to do now is play a video for you that I prepared ahead of time on this very fact. We're going to use Adobe Audition, and we're going to see how that we can do a passband filter, letting through the frequencies that we want, and how that we can filter out the frequencies that we don't want, and how that we can see that when we're applying these filters using an equalizer, that we can actually hear different frequencies stand out that might not otherwise stand out. So we can bring them to the foreground for processing by the human ear to be able to hear them. In a similar way, we can do frequency filtering in RF. So let's look at the video now. To demonstrate this concept of frequency filtering, we're going to be looking at a portion of a previous Wireless LAN News Desk audio track and see how an equalizer can be used to filter these out. So when we play it, so you don't necessarily have to write your own, you can hear what it sounds like. What I'm going to do is bring up an equalizer and we'll see what we can do as far as filtering. So the first thing I want to do is show how you can bring things to the foreground. Draw attention to it. You might say you're bringing it out of the rest of the audio. So what I'm going to do is go ahead and play it, and then I'm going to bring it out and let you see and hear it. Drivers that talk to the chipset or anything like that. All you have to do is connect this embedded module to whatever your device is, say a storage device or a toaster or a refrigerator, and then you can talk to the network through this embedded Wi-Fi module. So this is a component that could potentially be used in dozens or even hundreds of different devices that could then be sold as. Now there in that example, you could see that as I panned back and forth through the frequencies, you could hear a frequency being brought to the foreground, being focused upon. Now there's a little bit more that I can illustrate with this, and that is the concept of passband filtering. So what are we letting through? So this particular EQ has the capability to do that for me. So what I'm going to do is widen out a bit the area that it's allowing through. And let's go ahead and play it. And I'm going to click on a little button that allows me to only hear what that particular filter is doing. So I'm going to go ahead and play it. Having Wi-Fi. And this is one of the reasons why you see so many different. And there you can actually hear the reality that it's only allowing through certain audio. Let's move the location.
Have to write your own drivers that talk to the chipset or anything like that. All you have to do is connect this embedded module to whatever your device is, say a storage device.
So that's an example of what you might think of as passband filtering. Now what I can also do is more permanently filter things out. So I can actually choose to say that I want to have a low cut, and it's going to filter out all of the low things. And then I can come over here and say that I want to have a high cut, and it's going to filter out all of the high things. So similar to the concept of the passband filter, we're getting rid of things above and below it, and it's leaving us with a signal that looks reminiscently similar to a Wi-Fi channel. So now let's play this and hear what it sounds like. Or a toaster or a refrigerator, and then you can talk to the network through. So you can hear that it has indeed filtered out the stuff above and the stuff below, and all we have is that mid-range, which is the real meat of the voice. And by the way, if you didn't know that, this is where we're sampling for the old PSTN lines, and it's why audio on a PSTN line is not as rich as CD audio or even the audio of this recording. So now you understand a little bit about EQs, and of course this is audio, but filtering in the Wi-Fi world based on this is really in the vein of a similar concept, bringing you the ability to bring focus to the part of the frequencies you want to be focused on and to eliminate the frequencies that you're not interested in. Now, as you can see from that demonstration, we can filter audio, and we can bring something to the foreground, take something to the background, filter out everything we don't want and only hear what we do, and so forth. This is the concept of filtering in audio. And in RF, we can also do filtering. So we can filter and really bring attention to the 20 megahertz that is our channel, or the 40 megahertz, or what have you. And the key then is good filters. And this can be the difference between sometimes a consumer grade device and an enterprise grade device, is the quality of the things that are being used in that system other than just the radio itself. So keep in mind, filters are used, and now you know a little bit more analogistically about what they might actually be doing in your Wi-Fi gear. Well, that's it for today's Wireless LAN News Desk. I hope you've learned a little bit, and I look forward to being with you again next week at this same time. Have a great weekend.